This is the video on section 12.3, cylinders and cones. We already know how prisms work. A cylinder is a prism whose bases are circles rather than a triangle or a square or a rectangle or a hexagon. So we just have two circular bases that are connected vertically by a rounded edge. So a cylinder has a height, h, which is the perpendicular distance from one base to the other, and it has a radius, r, which is the radius of the circle that sits at either one of the bases. The two circles are congruent to each other, so they have the same radius. So we can find the lateral area of the cylinder, which is the area of everything other than the bases, and we can find the volume of what the cylinder can contain inside of itself. And we can recall how that worked for prisms. The lateral area for a prism was the perimeter of the base times the height, and the volume of a prism was the area of the base times the height. Well, we can use that same principle here because a cylinder is really just a special type of prism, a prism whose bases are circles. So the perimeter of the base is the perimeter of a circle, which means its circumference. And the formula for circumference, you'll remember, is 2 pi r. So the lateral area of a cylinder is 2 pi r times the height. The perimeter of the base times the height. The volume is the area of the base times the height. The base is a circle. The area of a circle is pi r squared. So the volume is pi r squared times the height. So it's really just an extension, a special case of the formulas for a prism. And so that's what our next theorems say. The lateral area of a cylinder equals the circumference of a base times the height of the cylinder, or the lateral area is 2 pi r h. And the volume of a cylinder equals the area of a base times the height of the cylinder, or pi r squared h. So let's try those. Let's use them. Example number 1. A cylinder has a radius of 5 centimeters and a height of 4 centimeters. Find the lateral area, the total area, and the volume of the cylinder. So the lateral area, what was that formula? Right, 2 pi r h. Do we know r? Yes, it's 5. Do we know h? Yes, it's 4. So we just plug those in. 2 pi times 5 times 4. Well, what's 5 times 4? 20 times 2, 40. We stick a pi on there. Now the units, if we were given centimeters as the units of our radius and our height, the lateral area will be centimeters squared. If your problem does not give you units for the radius and the height, then don't bother putting any units on the area. The total area is the lateral area plus the bases, plural, the two bases. Both of the bases are circles. The area of the circle is pi r squared. So we've got the lateral area, which remember is the sort of edges, the rounded part that goes all the way around, plus we've got two bases, and they're both the same, so 2 times pi r squared. What's r? It's 5. 2 times pi times 5 squared. 5 squared is 25, times 2 is 50, so we've got 40 pi plus 50 pi to give us a total area of 90 pi, and the units are centimeters squared for area. The volume, what was its formula? Pi r squared h. R was 5, h is 4. 5 squared is 25 times 4 is 100 times pi. The units for volume are the units of the radius and height cubed. Area is squared units, volume is cubed units. So there you go. Plug them into the formulas and you're good. Example number 2. The volume of a cylinder is 18 pi. If the height of a cylinder is 4, find the lateral area. This time we're given the volume, and we know the volume should be pi r squared h. We're given the volume as 18 pi. So that must equal pi r squared h. But we know h is 4. So let's plug it in. That means there's only one thing in the equation that we don't know, which is r. So let's solve for r. We can cancel the pi from both sides by dividing both sides by pi. We can divide both sides by 4, get 18 over 4 equals r squared. 18 over 4 can be simplified down to 9 over 2. 9 over 2 equals r squared. Good. So r is the square root of 9 over 2, which is the square root of 9 over the square root of 2. The square root of 9 is 3, so it's 3 over square root of 2. And we know, of course, that we don't leave a radical on the bottom of the fraction, so we'll multiply that out. Get 3 radical 2 over 2. That's the radius. What were we asked for? We were asked for the lateral area. What was the formula for the lateral area? 2 pi r h. We now know r, and we were given h. R was 3 radical 2 over 2, and h was 4. Okay? 3 times 4 is 12, times 2 is 24. 24 pi radical 2 over 2. Cancel the 2 into the 24 12 times to get 12 pi radical 2, which looks like a funny answer to have a square root and a pi on it, but that's our answer. That's the exact value of the lateral area. So those were cylinders, which are a special type of prism. Now, cones, which are a special type of pyramid. A cone is essentially a pyramid whose base is a circle. So a cone has one base, a cylinder had two bases. The cone has a height, h, which goes perpendicularly straight up and hits the center of the circle in its at the center. It hits the circle at the center, duh. And it has a slant height, L, just like a pyramid does. And it has a radius, R, which is the radius of the circle at the base. So recall the formulas for pyramids, and we're just going to extend those to work for cones. The formula for the lateral area of a pyramid was 1/2 times the perimeter of the base times the slant height, L. Well, the perimeter of our base is the circumference of the circle. So if we plug in 2 pi r, the circumference, for p, and we multiply that by L, then we have a formula for the lateral area of a cone. But notice the 2's cancel out. 1/2 times 2 is just 1. So the lateral area of the cone is pi r L. Pi times the radius times the slant height. The volume of a pyramid is 1/3 times the area of the base times the height. The base is a circle. Area of a circle is always pi r squared, so let's plug that in for capital B, and we have a formula for the volume of a cone, 1/3 pi r squared h. So that's what these theorems say. The lateral area of a cone equals half the circumference of the base times the slant height. So half of 2 pi r times L, which just reduces to pi r L. That's what you should write down. And the volume of a cone equals 1/3 the area of the base times the height of the cone. So 1/3 pi r squared h. We've got these two formulas that apply to cones. Don't confuse them with the formulas that applied to cylinders. We're going to have a lot of formulas in this chapter. So example number 3, find the lateral area, the total area, and the volume of the cone in the picture. So the lateral area, what was its formula? Pi r L. Do we know r? Yes, it's 3. Do we know L? No, it just says L in the picture. So we're going to have to find L. But notice that we have a right triangle, just like we did for pyramids. On a right triangle, we can always use the Pythagorean theorem if we know two sides, and we do. We've got 3 squared plus 6 squared equals L squared. L is the hypotenuse, so it has to be on its own side of the equation. 3 squared is 9, 6 squared is 36. What's 9 plus 36? That's 45. So L is the square root of 45, which can be reduced because 45 is 9 times 5. So L is 3 radical 5. So now we can use that in our formula for the lateral area. We've got pi times 3 radical 5. Multiply together the 3's to make 9 pi radical 5, which is the cleanest way to write it, to write the pi in between the whole number and the radical. There's the lateral area. The total area takes the lateral area, 9 pi radical 5, and adds to it the area of the base. The base is a circle. There's only one base for a cone. The area of the circle is pi r squared, but r is 3. So we've got 9 pi radical 5, the lateral area, plus 9 pi, the area of the base. Those do not combine together. They are not like terms, because the first one has a radical 5 on it. The second one does not. So that is our answer right there. 9 pi radical 5 plus 9 pi. And finally, the volume of the cone is 1/3 pi r squared h. So 1/3 of pi times r squared, r is 3, times h, which is 6 in the picture. So 1/3 of pi times 9 times 6. 1/3 of 9 is 3, and 3 times 6 is 18. So it becomes 18 pi. That's how much space is inside of the cone. That's what volume means. So lateral area, total area, volume. Example number 4. The volume of a cone is 4 pi. If the height is 2, find the lateral area of the cone. So the volume of a cone, 1/3 pi r squared h. We're told the volume is 4 pi. So 4 pi equals 1/3 pi r squared h. But h is 2. So 4 pi is 1/3 pi r squared times 2. Okay? We can cancel the pi's. So that 4 equals 1/3 r squared times 2. We can, hold on a sec. We can multiply both sides by 3 to get rid of the 1/3. So 12 equals r squared times 2. We're solving for r, so let's get rid of the 2 by dividing it over. 6 equals r squared. So r is the square root of 6. Okay. Find the lateral area. The lateral area of the cone is pi r L. We've got r. We don't have L. So let's think about our cone. It would help to draw it out. We've got the radius of the base, which is radical 6. It's perpendicular to the height of the cone, which is 2. And we've got the slant height L, which is the hypotenuse. So let's use the Pythagorean theorem. Radical 6 squared plus 2 squared equals L squared. What do we get when we square radical 6? It just makes the radical go away. So we get 6 plus 2 squared, which is 4. 6 plus 4 is 10. L is the square root of 10. Good. So now we know enough to be able to fill in the formula for the lateral area. Pi times r, which is radical 6, times L, which is radical 10. When we multiply two radicals together, we just multiply underneath. We get radical 60. Make sure we simplify that, because 60 is 4 times 15, and I broke it up as 4 and 15 because I know the square root of 4. Square root of 4 is 2. And I'll write the pi in the middle, 2 pi radical 15. Okay. Here are your immediate practice problems. You're going to draw a picture for each one. Find the lateral area and volume of a cylinder with a height of 4 and a radius of 3. Just apply the formulas. And find the lateral area and volume of a cone with a height of 12 and a slant height of 13. Again, draw a picture, apply the formulas. And that is the end of section 12.3.